Then let's say because we've already talked about the void ratio and moisture content and the unit weight. This table gives you the void ratio, moisture content, and dry unit weight of some typical soil in nature state. For example, loose uniform sand, the void ratio. For loose uniform sand, it's usually about 0.8. But for dense one, it may be around 0.4, 0.45. And the natural moisture content for loose one, if it is loose, that is for unit weight, that the solid particle is less, and the water is a lot, then your natural moisture content may be high, right? So higher than the dense one. And again, for the dry unit weight, because your solid particle is less, because you are loose, this is loose sand, so the dry unit weight is less than the dense one, right? So for loose angular grained silt sand and the dense one, again, you can go to the same thing, but you see that silty sand or dense, it doesn't matter loose sand or dense silty sand. The silty sand is higher, have a lower void ratio or higher dry unit weight than sand. Silty sand, that is, yes, it is sand. Sand particles is in a large content than silt and clay, but it also have some silt content, and the silt particle cannot be ignored because this soil is silty soil. And for sand, most particles are in a sand range. And you see why silty have a lower void ratio? Because silt particle, we say silt is a smaller particle. Yes, it is larger than clay, but it is smaller than sand. This is why this smaller can fill the sand particles, the voids between sand and sand particles. This is why, yes, the void ratio will be reduced, because small particles can fill those large voids between sand particles, right? And clay, stiff clay, soil, soft clay, they have a void ratio of about 0.6 or 0.9 to 1.4, and natural content a little bit high, because we say that clay can absorb water, because clay have minerals, right? The mineral can absorb a lot of water. This is why clay content is higher than the other soil. And loess is a kind of silt or silt clay, or sometimes the clay content is higher than silt. We can call it clay. Most loess is silt, and the void ratio. In here we say void ratio is a natural void ratio. That is, you go to the nature, you got a pound of soil, the void ratio is about 0.9. But in some engineering, we need to compact the soil. Now, the void ratio is not a natural void ratio because you disturbed the soil, right? We call it compacted void ratio. So it depends. In here, we say void ratio. It's a natural void ratio. This is water content, dry unit weight of the loess, and then soft organic clay, galencial till. Some typical soil, the void ratio, moisture content, and unit weight of some typical soil. And then let's see some relationship among unit weight, void ratio, moisture content, and we have another definition for specific gravity. How to drive this relationship? To drive this relationship, we usually consider the solid, soil solid is 1. We consider the soil solid is 1. Then the volume of voids is numerically equal to the voids ratio E. So we can go to those relationships. Try to understand this yourself. Try try to understand this yourself. We consider the solid is 1, then the voids of volume is numerically equal to the voids ratio E, right? You are sleepy, right? You are sleepy. So you are sleepy.
No.
No.
Yes.
So when the solid, what is voids ratio? Right? This is the original definition for voids ratio. And if we want to drive some relationship between volume and weight, so in most cases we want to simplify the problem, and we think that this is 1. You may think, why this is 1? If it is 2, can we calculate that? Yes, of course you can calculate it. Because if this is 1, so we in here equals to voids ratio, right? If this is 2, that is 2 voids ratio. So it is actually the same. This is why we use a unit solid volume. Why we consider the volume of the solid is 1. Because as long as this is 1, so the VV is equals to voids ratio. The total volume, then this is total volume, right? So you can simplify a lot those relationships. But if this is 2, right? If Vs is 2 in here, then VV, this equals to 2E, right? So in here you got 2E, right? So the V actually right? Actually, it's just doubled. It is the same. It is actually the same. So why we ignore this number in here? We can actually use 1. So we consider the volume of soil solids is 1, then simple allowed questions in here. Simple allowed relationships in here. For example, in here, if Vs equals to 1, then VV is voids ratio, right? So the total volume then it is E1 plus voids ratio. And later, this part will also be simple. So then the voids volume is equals to voids ratio, as long as we set the solids volume is 1. So the weights of a soil solids and water content can be expressed with this. Wow. In here, we have specific gravity of soil solids. Where is the specific gravity? I don't know how to explain it, but it is the relationship between these two. It is just like how to say, a constant value in a specific soil, a constant value of a specific soil. For this relationship, you just need to remember it, because we introduce a new definition in here, and this new definition later you will know what is specific gravity of soil solids. And we express the weight of solid with this. And then as long as you know this, for the water weight, then it equals to this. Why? Because water content right? This is the water content. As long as you know Ws and multiply water content, you got the weight of the water, right? Then you have this value, right? So in here, we introduced a new coefficient that is specific gravity of soil solids. So what is specific gravity? Let's see the definition. Specific gravity is defined as the ratio of the unit weight of a given material to the unit weight of water. So then for every single material, for example, for this is plastic, maybe solid plastic. For concrete, and maybe for metal, for any material, they have their specific gravity, right? Because you can always use the unit weight of such a material to divide the unit weight of water. That is why we use water to compare this, because the weight of water is usually fixed, right? It is usually fixed. No matter the water in Australia, or the water in China, or the water in your country, right? So the weight of the water is usually fixed. Then, if you want to how much of the weight of the other material, people usually like to compare the weight of this material with water. If we say that the material, this kind of material, the weight of this kind of material is 3 times to water, then in your mind you can somehow know how much of the weight of this material, right? So this is why people introduce the specific gravity in here, because the weight of the water is easily to be considered, and it is the same all over the world. But for the other material, it usually changes. For concrete, it may change. For plastic, it may change, because these are man-made material, but water is never change. And soil, they may change with different type of soil, right? So people use weight of water compare with other material to got the material weight, to calculate the material weight. This is in here we use specific gravity. So for a fixed material, it have itself specific gravity. For soil, it's usually around 2.7. It ranges from 2.6 to 2.8, but usually around 2.7 for most soil. Yeah, it lists in here. It is in here. That is the weight of, for example, for coarse. This is some mineral, not soil. For coarse, the specific gravity is 2.65. Based on this definition, that is for the same volume of water and this coarse, for the same volume, that the weight of the coarse is 2.65 times of the weight of water, as long as the volume is the same, right? So this is the definition for specific gravity. So what is specific gravity? Why we use specific gravity? It is in here. So if we go to previous slides, then Ws, then you can see Ws is a Gs gamma W, right? This is a weight, unit weight of water times the specific gravity is the weight of the material you want to calculate, right? That is, specific gravity is actually the ratio between the unit weight of the solids, soil solids, and the water weight, right? So this is specific gravity. In here, Vs gamma W, that is weight, a unit weight of the water, right? So the specific gravity of soil solids can be determined accurately through laboratory tests. This value it doesn't matter you remember or not this specific gravity, because in most cases, as long as you got a soil, maybe the nature density may change, or dry density may change, water content may change. As long as you spray more water in the soil, the water content may change, right? Degree saturation may change, but specific gravity never change. Never change. As long as it doesn't matter if it is a compacted soil or it is a natural soil, because in here it just relates to, it is the weight ratio between the water and this soil, right? It is the solid weight ratio. It is a ratio, so it never changes. It is always fixed. This is why we say cos it is 2.65. It is fixed. It never changes, right? So this is the specific gravity. It can be obtained with laboratory test. If you got a soil, you want to know how much of the specific gravity. We have machine to test it. You can got a small pound of soil and put in the machine. The machine will tell you or calculate how much of the specific gravity. And use specific gravity, we can drive a lot relationships between weight and volume. Let's say these derivations. So use the equation for weight of soil, solids, and water. We can drive equations for moisture and dry unit weight respectively as follows. These are just some relationship we derive from those very basic previous relationships. So in here, first, let's see the relationship between gamma and the voice ratio, and as long as, because we can test GS in laboratory, so GS can be easily obtained. And water content, you can use oven to go to the water content. Water ratio, of course, you can also got it. So the relationship between this and this, how to from here to here, is in here. We know that unit weight is a ratio of weight and volume, right? And the weight can be divided into two parts in here, right? Solids parts and water parts. And with specific gravity, we know that the solids part can be written into here, and the water parts can be written into here. Why? Because this is what? This is WS, right? WS multiply water content, that is the water weight, right? Because we know that water content is, right? This is water content. So in here, this is WS multiply water content, that is WW, that is the weight of water, right? And this is the relationship between gamma and voice ratio and GS and water content. So if you have no idea with these two, then you can calculate gamma with here. So why this is 1 plus E? Because we say set the solids volume is 1, then the voice volume is E. The total volume is 1 plus E, right? This is, we assumed at the very beginning when we draw this relationship, right? So this is one relationship. And if we drive this from this two, then we got this. This is the first relationship we drive for the unit weight. So unit weight can be calculated with this. And the gamma unit weight, the dry unit weight. So we say that dry unit weight equals to what? Right? Right? So in here, you have 1 plus a water content, right? That is this, right? So gamma equals to this. If you divided 1 plus water content, that is divided this part, you got dry unit weight. That is dry unit weight equals to this, right? Or you can directly draw it from here, from this. Understand? Are you confused? Some of you confused, are confused.
Confused.
Really? Confused from where? Solid. Oh, which one? Just tell me. I can explain because if you're confused here. You will just ask for soil mechanics. What? From which step? You can't say from beginning because I can't start over again. There is, you can express it.
I think, Lordship, can you start from when you started talking about the relationship of the weight of solids, weight of soil solids?
Weight of
W is from WS.
WS?
Yeah. Weight of soil.
Weight of solids. Weight of solid is the solid's weight. There is, if you say some relationship, you can understand. I explained to you. Weight of solids is the weight of solids.
Soil solids.
What is solid?
Soil solids,
Yes,
which equals to GS times gamma W.
So you confused from GS.
Yeah. Yeah, from there.
First, let's see what is GS. GS is a new definition in here. It's a new stuff we introduced in here. But it is important, so because later we will use GS in a lot of relationship to drive some relationship, and GS can be directly obtained in laboratory. That is a very important value. As long as this value can be tested, then you can use this value to drive out some other physics properties, some other physics parameters of soil. But what is specific gravity? Let's say the definition. It defines as a ratio of unit weight of a given material to the unit weight of water. Just read this carefully and just try to think it yourself. So it is a ratio, right? Ratio between what? Between two values. The first value is unit weight of the soil. In here it says given material. As long as it says given material, that is specific gravity. It's not only used to soil. It can use to many other material other than soil, right? So the first thing, the ratio between two stuff. The first stuff is unit weight of a given material. The other is the unit weight of water. So that is actually specific gravity is the number of how times of the weight of the material you study compares to the water. Why we use water? As I say, because water is the same all over the world. It is not like many other materials. It is the same. This is why people like to consider different material to water, because water is the same all over the world. And we know that how much weight of the water for a unit volume, right? That is a unit weight of the water. As long as you know this, then you compare the water weight with the material weight. Then you know the material weight, right? In here, specific gravity, you see, it is just some numbers. These numbers, that means, for example, let's see, cos. Cos is 2.35. That is for a unit weight of cos. The weight of cos of a unit weight of a unit volume of cos. It is the weight 2.65 times of the weight of water for the same volume. Understand? Understand? So when we say that, let's say elite is 2.8. When it says the specific gravity of elite is 2.8, then you need to react that, okay, for the same volume of elite and the water, the weight of elite is 2.8 times of the weight of water. Understand? This is the specific gravity definition. Right? So in here, we use this. This is the weight of the material. This is the weight of water, right? The weight of water, we just write it into why we write it into Vs gamma W? Because we compared the same volume. For the same volume of the material and water. So this is why we use Vs. Because Ws divided Vs, what is this? This is the dry unit weight, right? That is the ratio between dry unit weight and the weight of water gives you the specific gravity. It is the same with the definition words in here. Because we compared the same volume of this material and water. Because if the volume is not the same, you can't compare. You can compare 1 square meter of water with 10 square meter of soil. No, you can't, because the volume is not fixed, right? In here, we fixed the volume is the same. For the same volume, how much of the weight of the soil? It is the specific gravity times of the weight of this water. Understand? I want to explain this again. I think it is can't clear anymore. So when you say, again, just to keep in mind, when we say that elite, the specific gravity of elite is 2.8, then keep in mind that is for same volume of water and elite. The weight of the elite is 2.8 times of the weight of water. So we use the weight of water to calculate the weight of the material you want to calculate. It's just a comparison between these two. Understand? So this is GS, specific gravity. And you know the GS of the specific gravity.
So the weight of water.
Pardon?
Which one is permanent? Weight of water or specific gravity of water?
Which one is what?
Is constant.
Constant. Weight of water is constant. Unit weight of water is constant.
Is constant.
And then that is for different. That is constant all over the world, right? We know that the unit weight of water is 1. Or you say 1,000. It depends on what kind of unit you use, right? But GS for a different material, for a fixed material, for different soil in here, for example, different mineral, it is fixed. It is fixed. But for example, let's say soft soil, soft clay in Wenzhou. But soft clay in Wenzhou have a lot. For example, soft clay in the campus and in North Campus, it is different. Even it is soft clay, but you change. you changed the place the soil is changed. This is why soil is complex, because even you call the same name as the spot is changed, it always changed. If the depth is changed, so it also changed. But if you got the same soil in the same spot, it is definitely the specific gravity is constant. Why we didn't say soil in here? We use mineral because yes, when we say loess is kind of soil, but loess in France is different with loess in China, so the specific gravity changed. Now we consider loess is from two different places, it's two different material. This is why we use mineral, because mineral is pure, so it is fixed. If we say light plastic, or you give the chemical of the material, it definitely the specific gravity is fixed. This is specific gravity. Okay, and as long as you know the specific gravity, so in here we said that what is the specific gravity? It is the ratio of the weight to the weight of water, right? So specific, if you want solid weight, the solid weight, then it is specific gravity times of the unit weight of water, right? We say unit is 2.8. That means for the same volume, the weight of unit is 2.8 times of the unit weight of water, right? So this is why we have this equation. So you can use specific gravity to calculate the solid weight of soil. Because we know that the solid weight of soil in here, and we know that what is water content? Water content is the weight of water divided the weight of solids, right? That is weight of water equals to the water content multiply weight of solids, right? Then we have this. Because weight of solids equals to here, and then you have this. So it is 1 by 1 by 1, but the basic one is usually from the void ratio and from the water content, you see?
So, given the question in the exam, and then what to find what is weight of solid using specific gravity? Are we given the specific gravity, or are we supposed to?
Yes, you will give the specific gravity. Why give the specific gravity directly? Because specific gravity can be tested in laboratory, so you don't have to calculate it. You can't calculate it. You can test it. So as long as you can test it, why we give you question, ask you to calculate it? No, it's not. We don't, because it is for us the same soil from the same spot. It is usually fixed, so we usually tested this value. This is why for a specific question, it will usually gives you specific gravity, ask you use specific gravity to calculate many other things, because for the soil from same spot, maybe water content change, maybe dry unit weight change, but specific gravity not change. Okay? Yes?
That diagram which shows figures like the definite figures of, let's say, okay, can you go to the next slide, please? Yeah. Oh.
This?
Okay, this one, like, and this is always given, let's say, in an example. This is always given in the example.
No, we want to give you this in example. You say this is mineral. We never say this. You can't say a soil consists of one mineral. A soil is usually consists of a lot of mineral, right? It is complex stuff. We will give you in the examination. We will give, for example, we say we have a soil. The specific gravity is 2.7. We will give you the specific gravity of this. Of the soil, we will give you the mineral, right? And we will not only give you the specific gravity, you don't have to remember those relationships. You just need to understand them, how we drive them, derived them step by step, right? You need to understand them. You don't have to remember them because you can find such a table in the soil mechanics textbook, not the English one. The one I shared with you, there is no such a table. It is just in a Chinese textbook for soil mechanics. You see, for void ratio, dry unit weight, saturated unit weight, degree of saturation, and the porosity. You have different. This is the basic one, definition one, relationship, right? And you can drive from other parameters as long as you know the parameter. You don't have to remember. You see, a lot of relationship. You don't have to
Thank you.
remember that, but you need to understand how they comes from, right? How they comes from, right? Sometimes for a question, yes, you can find directly a relationship from the table and answer the question, but sometimes it's not. You need to combine two. At this time, then you need to understand why you need to combine these two relationships together, right? So you need to understand how this relationship comes from, how we derived from the basic one, okay? And maybe when you have an interview for a job, for a master, they will give you the same question to ask you some basic relationship. Why this relationship looks like this is why we derived the relationship, right? So you need to understand how we got them step by step. If I say yes, you don't have to remember. I don't have to remember why we have this chapter. We just have this table, that table, right? But we still need to know how we derived those relationships. So from the unit weight, from the as long as we know specific gravity, we can got this, right? I'm not sure if you still remember this after the interruption. Then let's see. So in here we got 3. This 3 was included in that table. But why we got this 3? That is from unit weight, the relationship between unit weight and void ratio GS and water content. And the dry unit weight between, this one is the most used one, between void ratio and GS and the void ratio. So how we got this? It is from here. You see, every single relationship is derived from the very basic one, right? Without the very basic one, you have no this step by step, and finally we have this. So the blue square in here is the main relationship we want to derive, and not only these 3. We have this, and later a lot, and others. And we included this in the table. And yes, I will attach this table on the examination paper because I don't think it is very important to test you if you remember the relationship. The main thing is that you need to understand that. It's not like I attach the relationship, you can answer the question. You need to understand, right? All right, we stopped here.